Well, look what the cat drug in. It's a fish to fry. Hey there, everybody. Welcome to episode number 497 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Guess what? We are talking about AI this week. My guest is Ben Gao from Cadence Design Systems, and we're chatting about bringing AI to the world of electronic system design. We investigate the electronic system design challenges engineers are facing today, the benefits that AI brings to electronic system optimization, and the details of Cadence's Optimality Intelligent System Explorer. Also this week, I examine a new laser charging system developed by researchers from Sejong University in Korea that was able to wirelessly transmit power over 100 feet. Before we get into that or bring in Ben, did you know that we are only a short number of weeks away from my super awesome 500th Fish Fry podcast episode? And this week, we launched a new AI and machine learning playlist on YouTube. If you're interested in the largest AI processor ever made, neuromorphic computing, or how AI can predict the weather better than the weatherman, you should check out this selection of Fish Fry podcast episodes. And you can binge them all at once by heading on over to the front page of eejournal.com or by checking out our YouTube channel, youtube.com/eejournal. All right, it's time to bring in Ben from Cadence and talk all about AI and electronic system optimization. Hi, Ben. Thank you so much for joining me.
Amelia, thank you for having me.
Absolutely. Okay, so first off, Ben, let's talk about some of the electronic system design challenges you're seeing engineers face today.
Sure, that's a very good question, Amelia. We've been working with lots of customers as Cadence, and we work with thousands of electronics design companies. We see clearly two trends right now going on in the industry. Number one is that design is getting more and more complicated. People are pushing the performance to the extreme. So we see that very often you need to consider more than one physics discipline. By that, I mean that normally we only need to consider electrical performance. But now that we have more customers, we need to worry about SIPI, thermal performance, stress, and so on. So it's getting more complicated. That poses a big challenge to lots of design activities. That's number one. I think number two, we are seeing that partially because of competition, partially because of the pace of innovation is accelerating. We see that the design cycle is getting shorter and shorter. So a lot of companies, they need to push the design teams really hard to get a product out of the design cycle to the market in a very short period of time. That's something like we have never seen in the past. So those two trends combined together give us a lot of opportunities to work with our customers to further improve their design flow.
That makes sense. Now, Ben, what exactly is MDAO for my audience who doesn't know? And along those lines, Cadence recently announced Optimality Intelligent System Explorer as well. So can you talk about those two things?
Sure. Like I just mentioned, design is getting more and more complicated. We have less and less time to design the whole thing. Meanwhile, we still have not relaxed our pursuit of the performance. We want to have the high performance system. So using the innovative algorithm to improve the final metric of the design. Now we look into this MDAO, multidisciplinary analysis and optimization. So by that term, we mean that in the design activity, we want to help our customers not look at the one single metric, one performance, one physics discipline. We want to have them look at multiple, including EM performance, electromagnetic performance, SIPI, thermal, stress, and very often now a lot of systems include photonics. So we also need to look at optics as well. So combine those physics together, we call it MDAO. We help our customers do simulation in these domains. And more important, we help our customers do optimization using the very innovative AI-based algorithm to help our customers optimize in these disciplines. So with that as a background, we launched a new product called Optimality Intelligent System Explorer to achieve that objective. So Optimality is a very unique, innovative product. We borrow some machine learning AI algorithm from our sister product called the Cerebras. That's an intelligent chip explorer Cadence invented last year to help our chip designers to improve the performance and the productivity on the chip design. And we brought that technology to the system space. We use that to help our customers optimize their electronic system performance. We use the deep learning algorithm to build a very accurate, very robust machine learning model to help our customers to explore the entire design space. Instead of using the time-consuming simulation to explore the design space, and we use regression model to do that, that significantly improve the performance and improve the final design quality.
Excellent. Now, let's talk more about the Cerebras Intelligent Chip Explorer. How is Optimality Explorer a logical progression of that?
At Cadence, we have been doing EDA chip design for many, many years. So we help chip designers to improve their chip design performance. So that's why we invented the Cerebras, using the machine learning, the AI algorithm, to help our designers to explore the design space in the chip paradigm. And now that after we launched the Cerebras, we got a lot of positive feedbacks from our customers. They're really, really happy to see that how this new algorithm can help them improve the performance, improve the productivity. So we quickly realized that same algorithm can be borrowed, can be transplanted into the system space to help our customers to bring that paradigm to a new space, new dimension, to help them explore the whole system space. So we define the system performance metrics in that very early stage before we even start talking about a package PCB chip. That's the background. So after we implemented the algorithm into Optimality, and we have been working with several very leading customers to do beta testing, we're really, really happy to see the fabulous results. And the results we got is sometimes just incredible, too good to be true. We believe that this machine learning based algorithm in Optimality can help our system designers to further improve their productivity. We're really excited.
Excellent. Let's step back a little bit and talk about the benefits that specifically AI can bring to electronic system optimization.
Typically in the past, that our designers, they have been using simulations to improve, to verify their designs. That typically that one designer can optimize, can try to use his heuristics experience, like up to 10 or 20 parameters. The problem of doing that is that you can only handle a limited number of parameters. And also the whole design process can be really time consuming, can be really slow, because it can take you weeks to run through all the simulations for you to manually identify the best setting. But using this Optimality algorithm, we can help our customers to quickly identify the best design parameter setting to achieve the optimum performance. I'll give you a quick example. In the process of developing Optimality, we work with Microsoft. they give us a very challenging design to optimize interposer of the 3D IC design. And traditionally, if we use manual work to do the optimization, that will take you like 3 to 4 weeks. But with Optimality, combined with Clarity to do the simulation in the background, we can launch multiple simulations in parallel. So you combine all this power of computation, the algorithm, and the parallelization together, we help customers to achieve the best design, the best results within a couple of days. So we're talking about more than 10x design productivity improvements. That's why the whole company is really excited about the potential of this AI-based algorithm.
Fantastic. Ben, this is super cool. All right, before I let you go, it's time for your off the cuff question. Now,
Sure.
since you haven't been on my show before, you get the standard off the cuff. So, Ben, a lot of us can't have our favorite foods these days for one reason or another. Either it's lockdown, lack of the ability of travel, the restaurant's closed, maybe. But, Ben, if you could have one meal right now, doesn't matter if it's from the other side of the world, what would you have?
You know that I've been living in Texas for 20 years, right? Of course, that my number one food to go is steak. That ribeye is my best choice, if I can.
I love it. Okay. Simple and perfect answer. All right. Well,
And Amelia, when we have chance to meet, I'd like to take you to the best steakhouse in Austin. We can have a good time.
Fantastic. Where is it?
It's I think I have quite a few favorite steakhouse in Austin, but recently I go to Paris quite often. They have a pretty good steak and lots of choices.
Call it a deal. I'll take you up on that. Thanks so much, Ben.
It's my pleasure.
What if you could just walk into a room and charge your phone? No pad, no cord, no nothing. What if the power you needed for your mobile or IoT device came from the air? Well, a team of researchers from Sejong University in Korea have done exactly this. They have developed a new long-range wireless power transfer system that uses infrared light to safely transfer high levels of power. And how high, you ask? Well, in their tests, this team was able to transfer up to 400 milliwatts up to 30 meters or around 100 feet. So that's enough for sensors, sure. But this team contends that with further development, that the amount of power could be increased to charge mobile devices as well. So, at the heart of this new research is a power transfer method called distributed laser charging. And it works kind of like a traditional laser, but slightly different. Instead of optical components integrated into one device in the laser cavity, they are actually separated into a receiver and a transmitter. A laser cavity is then formed when the receiver and the transmitter, are both within a line of sight, which allows the system to deliver light-based power. Now, I hear you guys loud and clear. But what if something gets in the way? Well, if an obstacle does get in the way of this line of sight, the system automatically switches to a power-safe mode. Okay, there are two important aspects of note in this research, and they both involve, yep, you guessed it, safety. So, first, this team used an Ebrium-doped fiber amplifier power source that has a central wavelength of 1550 nanometers. That's important because that wavelength poses no danger to eyes or skin and is the safest region of the spectrum. Another important safety aspect is the division multiplexing filter used by this team, because that filter is able to create a narrow band beam with optical power that is within safety limits for this kind of propagation in free space. And the results of these experiments, were pretty intriguing. They were able to provide an optical power of 400 milliwatts with a channel line width of 1 nanometer over a distance of 30 meters with their single channel wireless optical power transfer system. And then a receiver unit that includes a retroreflector, which is a photovoltaic cell that can convert optical signals to electrical power, was able to convert that optical power to 85 milliwatts of electrical power. And in these tests, they were also able to demonstrate that safe power mode as well. When a human hand was in the line of sight, the system automatically shifted to safe power mode. It still transmits in this mode, just at a really low intensity light that doesn't pose a risk to people. So the potential of this kind of wireless power transfer goes way beyond charging the phone in your pocket. Sejong Ha, one of the researchers working on this project, says this about the future opportunities for this kind of technology. He says, using the laser charging system to replace power cords in factories could save on maintenance and replacement costs. This could be particularly useful in hazard environments where electrical connections can cause interference or pose a fire hazard. So, where is this team from Sejong University headed from here? First, they are concentrating on the practicality of this technology, including increasing the efficiency of that photovoltaic cell, and the development of a plan for the system to simultaneously charge multiple receivers. Super cool, right? So if you want even more information about this powerful new technology, I've included a couple links below the player on this week's fish frying page on eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel. That's right, youtube.com/EEJournal. Folks, it is chock full of all kinds of popular techie videos, including our Chalk Talk webcast series hosted by yours truly, and those new fish fry playlists as well. And remember, you can subscribe to our EE Journal YouTube channel too. Also, by clicking the links below the player on this week's fish frying page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's fish frying page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of September 2nd, 2022, I'm Amelia Dalton, and you've been fried.